Another example of graphing using transformations, right? For this one it says, hey, example 2 on page 400 of your textbook can help. Okay? I want to graph negative sine of 2x. Well, let's think about those transformations. What were the two transformations that I had? One, I reflected in the x-axis, and two, what happens with the 2x? With the 2x, I compressed horizontally by 2. Right? I compressed horizontally by 2. I reflected the x-axis. Okay, so once again, this general sine function, right? If I had generally just y equals the sine of x, and then I'm going to compare it to sine of 2x. Well, sine of x at 0, 0. Half a revolution, 0. A full revolution, 0. Okay? And, generally speaking, right, at 90 degrees, a maximum, at 270 degrees, a minimum. Okay? But, what's going to happen here? One thing I've done is I've reflected the x-axis. I reflected the x-axis. So now, for my function, instead of my function starting upwards, my function is instead going to go downwards. Right? Instead of going up, when I reflect the x-axis, I'm going to go down. Okay? But what else has happened? I've also compressed horizontally by 2. So that means that rather than taking 180 degrees to get to 0, it's going to get to 0 in half of that time. So at 90 degrees. Right? And rather than having a 0 at 360, it's going to take half that time to get to a 0. It's going to take 180, right? And here, then, this is going to repeat every 90 degrees. So 90 degrees, add again, 90 degrees, here it is, and again, 90 degrees, there I am, right? And I know I start going downwards rather than upwards because I reflected the x-axis, right? But there is no vertical stretch. So here is the minimum halfway between. Here is the maximum halfway between. The minimum halfway between. The maximum halfway between. Right? And I can look and play, connect the dots. So there is my graph. Very important that I do put in, right, the y-axis values. And notice that this distance that it takes for the graph to repeat, right, this distance that it takes for the graph to repeat, okay, not from here to here, because this doesn't repeat, but rather going all the way from here, all the way to there, right, then up, down, then up, down, right, this is the period, right, and that period, that period is going to be decreased by half. So the period in this case is going to be pi, because pi is half of 2 pi, right? That's how long it's, that's how much distance or how much time it's going to take to do one repetition of this. And of course I can do it going backwards. Well, if the period is pi, right, which is 180 degrees, right, then I know at here, and here, and here, and here, right, at every half period, right, 90, 180, 270, 360, at every half period, I'm going to be on this central axis, right, and if I follow my pattern, this would go up, so maximum, then I'd go down, so minimum, go up, maximum, go down, minimum, right, and I just keep on following that pattern, play, connect the dots with this nice smooth curve, right, play, connect the dots with this nice smooth curve, and there is my sine function. Once again, what did I do? I compressed horizontally by 2, that changed my period. I reflected the x-axis, that changed from going up first to going down first. Okay. We can repeat that process. We can repeat that process when we're working in radians, right? period of pi, right? Period of pi, half a period, I'm also on the central axis. Half a period, I'm also on the central axis, right? Instead of starting positive, because I reflected the x-axis, I start negative. So, right over here, right over here, right over there, right over there, right? Down, up, down, right? And repeat the pattern going backwards, right? And always make sure that you label your axes well. So repeat the pattern, max, min, right? And I can set this up, this wave-like pattern that gets called a sinusoid, right? And you might miss, just a little bit, hey, this isn't quite exactly on here, but we can clearly see the minimums, we can clearly see the maximums, we can clearly see where we are on that central axis, we can clearly see the shape. That's very important for sketching our graph, right? So that is working with the sine